Hello everyone, what I've got here is the circuit for a Surveyor drone that will be used in a roofing operation. So we'll start with the Arduino Uno R3. You can see that I've got 5 volts going onto the breadboard that's connected to all these other components. We've got 4 DC motors that will be driving each one of the propellers on the drone. The rear DC motors are driven off of this L293D motor chip here. The front motors are driven off of this chip here. You can see from our 5 volts here, we've got 5 volts going into enable here and to power on this side. And same thing on this chip, we've got 5 volts coming in here and here. To power the motors, you've got a 9 volt battery over here that is then connected to each motor chip on the terminal 8 here. On the front of the breadboard, we've got an IR sensor that's going to be used in conjunction with the infrared remote. We've also got the photoresistor on the front. I'm using a photoresistor in place of a camera just because Tinkercad does not offer a camera in their simulations. The last component we have is this ultrasonic distance sensor that'll be measuring distance of any obstacles that the drone can run into, and then measuring the actual distance from the ground and the roof. And again, any obstacles like power lines, tree branches, anything like that. So if we look at the code here, start out with this include IR remote line. That is telling the simulator which button on the remote is doing what. It's finding the library for that remote. First section here is setting the pins for each item. We've got a threshold section here. So reverse threshold is 10 inches, which is anything below that. The drone is going to put all motors in reverse. And the camera shot minimum altitude is 20 inches. I'm using 10 and 20 inches just because of the capabilities of the distance sensor. So this section here is the settings for each pin that control which direction the motors are going. So there's stop, forward, reverse, and left to right for each motor. And you can see we're setting low and high, and that just changes the rotation of the motor. Okay, so we're measuring distance here with the sensor. This is where we're setting the modes for each one of the pins, so whether it's an output or an input pin. In our loop section here, we've got the button push commands. So you can see here button 1 is forward, 2 is left, 3 is right, 4 is reverse. And let's see. Okay, so the last thing we've got obstacle avoidance and the camera trigger simulation. So again, if this gets less than whatever I set the threshold at, the drone is going to reverse to get away from the object. And then the camera trigger simulation, you'll see when I slide this photoresistor, we'll see picture taken on the serial monitor. So when we start our simulation here, okay, so when we press, let's get it away from the object. When we press 1 to move it forward, I've got these motors running for 5 seconds at a time. The idea being that it gets into position and then it can take its picture. See at the bottom we've got picture taken. And then we can move to the next position. Take the picture. And so on and so forth. You would repeat that until you have enough measurements to compile the data of a whole roof job. And that would be used by the nailer bot to determine where shingles will be placed and to work around objects on the roof as well. Thank you.